To begin, let's look at the parent function of the cubic function. Let's start by filling in the graph of the parent cubic function. And we're going to use -8, -1, 0, 1, and 8. When I'm looking for cube root, I'm looking for a number that multiplies by itself 3 times to get another number. So -2 times -2 times -2 is -8. Therefore, the cube root of -8 is -2. So the cube root of -1 would be -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 8. Let's sketch the graph. Just like the linear and the cubic function, the domain and range of the cube root function are all real numbers. Now when we are transforming the parent function, we are moving the original spot, which is 0, 0. So this is what we're actually shifting. And this is the pattern. Now let's look at some effects on the parent function of the cube root. Since we have done several transformations already this year, why don't you stop the video, fill out the transformations, and turn it back on and see how you did. So how did you do? Let's describe what's happening to the parent function to get our new graph. Let's use our key points to get our new points. Let's find our HK and then graph. So to begin, this is a graph that's reflecting over the x-axis, and it's moving up 4 units. Let's find HK. H is 0 and K is 4. So while the old graph started here, the new graph begins at 0, 4. And just like in the square root, the quadratic, and the cubic function, once I use HK, I'm not using HK anymore. I just need to know what am I multiplying to x and y. To get the new points, we are only multiplying the old points by the reflections, stretches, and shrinks. That's it. So the only thing I'm multiplying is what's in front. So let's look at this equation. I have a negative sign out front. So this is saying let's multiply the y by a -1. There's nothing in here with the x, so x stays the same. So I'm going to bring down all the x values that are the same, and we're going to multiply the y values by -1. So all the y values will change their signs. Now let's graph this new function. Remember, this new starting point, this new shifting point, is where we graph all of our new values. So it's almost like it's a new origin, even though it's not. So let's graph. What is happening in this function? We have a vertical stretch by 2. And we have horizontal movement right 3 units. Let's look at HK. h had to be a positive 3 for our function inside to be x minus 3. And k is 0. So the new starting place is right here at 3, 0. Now remember, the old values of the cubic root parent function were negative 8, negative 1, 0, 1, and 8 for the x values, negative 2, negative 1, 0, 1, and 2 for the y values. We need to figure out what are the new values, what's happening to x and what's happening to y. Remember, I'm only multiplying by the stretch and shrinks. There is a vertical stretch of 2, so let's multiply all the y's by 2. But there is nothing being multiplied to x. So x stays the same. 2 times negative 2 is negative 4. 2 times negative 1 is negative 2. 2 times 0 is 0. 2 times 1 is 2. And 2 times 2 is 4. Now let's graph this. Let's write down all of the transformations. Notice there's nothing out here being multiplied to y, so y stays the same. But inside x, I have a horizontal stretch of 2. Our function is moving right 1 and up 1. So h is 1 and k is also 1. So the new function will start at this point. Let's look at all the old values. So for all the x values, we're multiplying by 2. And all the y values we leave alone. Now let's graph this function. Now let's write the equation of the graph pictured. Well, first off, let's look at it. If this is 0, 0, what did it do? Well, we know it moved down how many units? 4 units. We know that this is a reflection. This graph has a horizontal shrink by 1/2. So let's write this equation. Y equals negative the cube root of 2 times x minus 4.